Hello, everyone. I'm going to discuss confidence intervals. And the first one that I want to talk about is finding the confidence interval for the mean when you know what the population standard deviation is. Sigma is known. First of all, the level of confidence that we establish for the interval that we're going to determine we'll call C, and that's simply the probability that the interval estimate contains the population parameter, um, the mean, in other words. And we're assuming, of course, that that estimation process is repeated a significant number of times, a large number of times. The level of confidence then is the area under the standard normal curve that is between the two critical values, which we'll talk about next, and we'll call those negative z and positive z. So consider this problem. We're interested in the mean scores on an exam, and we want to find the confidence interval for the population mean with a 90% confidence level. We know that the population standard deviation, sigma, is 3. We know that the mean of the sample that we are pulling out is 68, and we know that the size of that sample is 36. So if you know those three pieces of information, then you can go to this little chart, which I suggest that you write down quickly in your notes. If the level of confidence that we are working with is 90%, then our z sub c value will be 1.645. If it's 95%, it's 1.96 and so on. And these are the typical confidence levels that you're going to be working with. So just keep those numbers handy. Now we can substitute for negative z sub c, negative 1.645, and likewise positive on the other end. Okay, we now need to find the margin of error. And the formula for margin of error is E equals, that should be Z sub C, times sigma over the square root of n. So plugging in those numbers from the previous slide and calculating that out, we get E is equal to 0.8225. So that determines the confidence interval. We're going to take our sample mean, which was 68. We're going to subtract the error to find the left boundary for the confidence interval, and we will add the error to find the right boundary. And I'm rounding these to two decimal places. So we come up with the confidence interval 67.18, 68.82. And we can state with 90% confidence that the true population mean is going to fall in that region. Now, in the next slide, I'm going to show you how to avoid having to hand calculate and use Excel instead. The function that we use in Excel is confidence.norm, and it needs 3 parameters. The first is alpha. If the confidence level is 90%, then 90% falls inside the confidence interval and 10% falls outside. And that is your alpha value, 10%, 0.10. And if you remember the diagram, that 10% is actually split into two tails, 5% on each side. But alpha is equal to 10%. Sigma, we were given as 3, and n we were given as 36. So plug in those 3 parameters in cell A1, and it returns the value 0.822427, which is slightly different than the value we hand calculated, but notice same accuracy to 2 decimal places. So that determines the confidence interval. And of course, what I did here is I just put a formula in cells B3 and B4, 68 minus A1 and 68 plus A1. Okay?